So we still pay special attention to momentum and impulse. Now let's consider the statement. It says a ball X of mass 10 kg is moving eastwards with a velocity of 2 meters per second. It collides elastically with another ball Y of mass 2 kg, which was moving with an unknown velocity, Vy, as we can see in diagram A. Immediately after the collision, ball X comes to rest and ball Y moves eastwards with a kinetic energy of 36 joules, as we can see in diagram B. So they don't give us the final velocity of Y, they give us the final kinetic energy. Well, these people are smart, but they say ignore friction. So meaning this is an isolated system. The first question says, explain the meaning of the term elastic collision. So you'll tell them it's a collision in which the total kinetic energy of the colliding objects in a system is conserved. Alternatively, you can say it's a collision in which the total kinetic energy before the collision equals the total kinetic energy after the collision. Any of those two. Fine. Then the next question says, calculate the velocity Vy. But before we can do that, firstly, we need to find the final velocity of object Y, ball Y to be exact. So let's go and do that. Well, in order for us to find this velocity, it comes from the definition of kinetic energy. So we know that kinetic energy is half mv squared. They told us it's 36 joules. Then we say half into the mass of object Y. They said it's 2 kg. And then we times it by v squared, like that. Now, half times 2, it's just 1. So meaning we have v squared equals 36. Then we apply the square root on both sides. Our velocity is plus or minus 36. But because it's moving to the east, let's choose to say anything that goes to the east is positive. So it means the final velocity will be positive 6. Now that we have it, then we can go and conserve linear momentum. So we say the total momentum before the collision equals the total momentum after the collision. If we look at object X, it's the mass of X times the initial velocity of X. Then we say plus. We take the mass of Y, we times it by the initial velocity of Y. So this one, we can leave it as Vy. Now we say this is equal to the mass of X times the final velocity of X plus the mass of Y times the final velocity of Y. Then we said the mass of ball X is 10 kg. It's moving to the east at 2 meters per second. The mass of Y is 2 kg. We are looking for the initial velocity of ball Y. Then we say the mass of X is still 10, but the final velocity of X is 0 because it comes to rest. The mass of Y is still 2 kg, but the final velocity is positive 6 meters per second. Now, on the left-hand side, I'm left with 2 Vy. Well, 10 times 0 will just be a 0. 2 times 6 will just be 12. 10 times 2 will be 20. So if I take 20 to the right, it becomes negative. 12 minus 20, we get negative 8. After dividing both sides by 2, it means Vy will be negative 4 meters per second. But now the question said, calculate the velocity. Then you must conclude and say, therefore, Vy equals 4 meters per second to the west, both magnitude and direction. And then you should be fine with this one. So what does the next question say? And momentum and impulse, guys, is actually 3 marks. You're not supposed to lose even a single mark here. Remember, the aim is to go to the top 100. Fine. Now they say the balls were in contact with each other for 0.1 seconds during the collision. So we are given the contact time. The next question says, calculate the magnitude of the net force that ball X exerted on ball Y during the collision. So in other words, what is the net force acting on ball Y? Do you see that? So because we are given the time in this case, we have to define or rather state Newton's second law in terms of momentum. So we say the net force acting on ball Y, is it ball Y? Let me check. Yes. So I'm saying the net force acting on ball Y is equal to the rate of change in momentum. So it's up to you if you say it like this, or you represent your change in momentum this way. It's up to you. But because we are given the time already, ours is to find the change in momentum. Then we can say change in momentum divided by the time, and then we get the net force over and out. Now, what is the mass of ball Y? So we know that it's 2 kg, but the final velocity of ball Y, it's 6 meters per second minus the initial velocity of ball Y. We found it to be negative 4 meters per second. And then we say everything is divided by 0.1, the contact time. So if you plug everything into your calculator, you say 2 into 6 minus into negative 4 divided by 0.1. Then you find that it's going to be 200 newtons. This is the magnitude of the net force that is exerted by ball X on ball Y. And then you are fine. Well, of course, there are many ways to kill a cat, right? You could have decided to start by finding the acceleration. Then you can use Fnet equals ma. But in order for you to find the acceleration, you'll have to use equations of motion. Imagine. So you're actually doing it the longer way for just 3 marks. Come on, guys. Why do you want to waste time when you can go straight to the answer? So yeah, this is the best way for you to do it. And then you should be fine.